Are we in? I think we're on. We on, Jamie?
I think so.
Cool.
I don't see us on Twitch. Oh, yeah, we go.
Oh yeah, we are now. All right.
Excellent. I shall just get off the work VPN.
It's a good time to do that. Yeah.
Yeah. Yeah, they don't particularly like it when we stream video across the. Cool. Let's. We have a person.
Yeah, we are definitely live. Hello there. Hello. Do you want to go for it, Andy?
Yeah, I can talk. Hi, everyone. We're not going to get started properly until around 10 past. We're just going to see if anyone wants to ask any questions about the user group, or if anyone wants to talk about what sort of things they're using Rust for in the chat, and we'll just have a chatter until we start properly at 10 past.
Yeah, absolutely. One of the good things about online meetups is that people can arrive pretty quickly. It's kind of a handy thing. Already up to 35 viewers. That is not bad at all.
Yeah, it's very good.
Yeah, absolutely. Cool. So yeah, hello from us. We're going to be Rust Manchester. We've got Ryan and Neil with us tonight, and thank you to them. I'm sure their talk's going to be wonderful. Yeah, we're starting this up from scratch, so we still got to figure out exactly what that means, what people want. We want you to tell us what you want. That's a pretty classic thing to say, and we do. And yeah, I'd say we want to figure out what this meetup is to Manchester. There are quite a lot of Rust meetups in the UK, and obviously we want to kind of have our own spin on it. So let us know what it is that you want to do and you want it to be. Yeah.
I was going to tell everyone about the crab emoji. Other
Go for it.
Other Rust meetups I've been to where the crab emoji is a thing. People use the crab emoji instead of a clapping symbol. However, I can't find it on Twitch. Is it something
I
missing?
think we've got to add it custom.
Oh,
basically.
no, that's
yeah.
We should have tried that first.
Oh, there's some crab emojis. There's some crab emojis turning up in the chat. That's the main thing.
Excellent. Yeah, brilliant.
Wouldn't be a Rust meetup without it.
No. Yeah, I must admit I missed the beginning of the first one I saw the crab emojis on. I missed the beginning of it, and people were just posting crab emojis. I was like, "What on earth is this crab emoji thing about?" It's like, I've clearly missed something here. And then someone pointed out rustaceans, crustacean, crab. Like, yeah, of course, really obvious.
Follows logically, absolutely.
Yeah, but you know how these things work. You don't always make the jump at the time, do you?
No, absolutely.
Cool. We have quite a few people, 40 people joined now. Just for interest, how many people in the chat at the moment actually use Rust in their day-to-day working lives?
Let's hope we get some answers.
Yeah, it's a bit quiet.
It is. I'm sure they'll come in. There's a little lag. There is a little lag usually between.
Oh, Rick. Hi. Hey, Rick.
Yeah.
There's one. 0.05, I do a bit, but it's not my primary. Howdy. I managed a little side tool made in Rust and wait to test the waters. Excellent. Cool. Can't see anything or hear anything.
That's concerning. Can other people see and hear things? Let's make sure that we're not like quite that messed up.
I actually have the Twitch stream up over in here. That's why I keep looking at it. It is there.
Okay, cool. Other people can hear. Right, we're good. Sorry, Lucy Hudson. You may need to reload. Yeah. So we probably should. I was going to say. For us at Rust Manchester, so it's being organised by myself. I don't do Rust at work. Maybe one day I'll do Rust at work. That would be very nice. The yeah, I'm predominantly here because I can organize meetups, and I run another meetup called Lambda Lounge, which is a functional programming meetup. So that's my involvement. Andy, you might, yeah, you have done Rust before.
I have, yes. I actually worked with Ryan, as it happens. For 2 years, we worked on some Rust, mainly IoT development, and some network comms, and some of the stuff he's going to talk about today. Actually, yeah. Unfortunately, I now had to get a real job in .NET, so never mind.
Yeah, and I'm Jamie. I also organise this here. I actually do work on Rust, and so I'm the only organiser that seems to work on Rust. So that's
The only person on the call that knows anything about it, you know. No, not quite that bad.
Who on the chat is using it on a just to play around, projects, and or is just very interested in learning it?
Me.
Yeah.
Very interested in finding out what Rust is tonight. Yeah.
It's performance critical, and I'm not using a GC based language. Yeah, yep. It's definitely one of the use cases for Rust.
Cool.
My comments are scrolling.
So
we should probably say the system that we're using for this is new to most of us. So if we look like we don't know what we're doing, it's mainly because we don't.
You don't need to be that honest.
Yeah, I made a little hyper web server thing, but looking to use libp2p. Oh, exciting! Yeah. That's good. Play around in projects and some Advent of Code. Oh, brilliant! Yeah.
Advent Code's a good one to start doing these things. With Advent of Code, I wrote a few of them in Scala, and then I compared it to an Advent of Code that someone else wrote in Rust, and realized Rust was about 100 times faster, which made me quite sad. Sorry, Scala. I love you, really.
The user count has been stable for a while. I know we said to start at 10 past, but
yeah, maybe Jamie, do you want to do the ARM stuff, because you really should?
yes. So I'm my employer, but yes. So yes, ARM provided some sponsorship for this event, so huge thanks to them for that. We are hiring. Some of the roles might involve some Rust as well, so definitely take a look on the careers page. You can scan the QR code to go to careers.arm.com, and yeah, just take a look there and see if anything takes your interest, I suppose.
Absolutely. Cool.
Thank you, Jamie. Shall we get started then? You think?
Yeah, I think let's start. So
cool. Well,
yeah,
thank you everybody for joining the very first Rust Manchester. I know there may be a few people who managed to do the one Rust North event. I actually managed to organise. This is so just to explain where this kind of came from. Rust North obviously was failing to get off the ground, and James and Jamie decided that they really needed a Rust Manchester user group, and so they approached me, and the three of us decided to join forces and actually make this thing happen. And then, as Jamie pointed out, ARM has offered to sponsor, which is amazing. It's really helpful. So the way this is going to work today is we're going to have a quick talk by Ryan Roberts for about 20-25 minutes, and then we're going to have a talk from Neil afterwards, which will be another 20 minutes, and then we're going to take questions from the audience at that point. If, however, you've got any questions during the talk, feel free, put them in the chat and the comments. And what we'll do is we'll pick them out at the end and decide which ones we want to ask. Hopefully get through all of them if we can. And then after we've taken questions, we're going to try and open up the floor a little bit to have a little chat about the future of the group and what people want from this user group. Cool. Yes, I'll hand over to Ryan Roberts, who's going to talk about using Rust to do cross-platform mobile development.
Hi, I am Ryan Roberts, and I'm going to talk about using Rust to use cross-platform mobile development. I'm an engineer at Sand Digital. I have used Rust to build mobile applications before, and well, we all want an excuse to use Rust professionally, and I'm going to try and give you one for using it for mobile development. So the first thing to probably go through is what mobile development is, and it's not just mobile handsets or tablets. There's a really diverse ecosystem of devices out there, particularly with Android. There's televisions, and there's a huge embedded system space which uses Android as a platform because it's a relatively easy way to get a touchscreen user interface working. So light switches, televisions. I mean, there's even boat navigation software which is based on Android now for the touchscreen interfaces. So the iOS, there's also Apple's ecosystem, which is also sometimes involved in lower level things, but we don't actually need to do much of that to utilize Rust reasonably for mobile development. So there's four main approaches to building mobile applications currently. There's building two separate applications using the manufacturer's toolchains. There's cross-platform native toolchains like Xamarin and React Native, and lastly Flutter. There's cross-platform hybrid UI, which is Cordova and Facebook's older application. And then there's whatever game developers do. So native separate applications is probably the best approach if you want very high quality applications. So what you would do is use the manufacturer recommended toolchains to build two separate applications, which hopefully do the same thing, but in a way that is appropriate for the device that it's running on. This is it's the best way to get the user experience and performance that most closely matches the device capabilities, because there's the least abstraction. It can, of course, have some issues that you're probably going to end up with two teams, and you're probably going to end up with two backlogs, and you're potentially going to get a lot of divergence. So it can be expensive and a difficult way to manage relatively simple applications. So for smaller companies, well, in fact, Facebook initially tried this. Then there's various cross-platform ways of trying to develop a mobile app, where you would write most of your code that would execute on both platforms, and then you would map it to the APIs on the underlying platform. So probably the most common one for this now is React Native. So they all work in a similar way, and you get an abstraction of the user interface and an abstraction of the non-user interface components of a mobile application. And your application talks to those. And then there's a bunch of complicated magical mappings which hopefully do the correct things on the underlying native platforms. This can be problematic for all the obvious reasons. You often end up with leaky abstractions, particularly around performance and various user interface quirks which don't quite map onto the platform that you're using. Xamarin in particular is quite infamous for this. The other way of doing it is cross-platform and hybrid UI, where you're effectively using a browser as your primary portability layer. So you write most of your code using web technologies, and the native functionality is injected into the DOM. And so there's a cross-platform bridge underneath the DOM, which then diverges into the appropriate API calls natively. So the primary difference there is you don't get a native user experience; you get a web user experience, which you can style and make look pretty much like the native user experience. This is it's quite a common pattern for less ambitious mobile applications, and also if you've got a lot of existing web assets, it can be a relatively easy port. One issue with it is that again, the leaky abstraction problem. If you do get a problem with the native integration, even though they're not usually visual problems, you do actually have to understand the underlying platforms, which can cause problems in some projects if you don't actually have anybody on hand who is an expert on the underlying platform. So, and then there's game developers who basically do what they want. I mean, you can run Doom on anything, right? There's actually a really nice Rust project I just saw called Cargo Mobile, which does a very nice. It looks like it packages games for multiple mobile platforms. So, why would we use Rust for mobile development? So there's a bunch of non-visual components which you can write quite effectively in Rust. If you have a complicated protocol, if you're not just speaking HTTP, if you have say binary MQTT, or if you need to do MDNS discovery of devices on a network, or various fiddly things that you wouldn't want to write twice, you wouldn't have to maintain on two platforms, and you probably wouldn't want to write in languages that begin with J, then you can create components and map them into all three ways of developing mobile applications. So you can write a cross-platform non-visual component in Rust and map it into the native layer for both iOS and Android. So how would we do it? Pretty much, you can just write Rust. You can write anything in standard Rust. You can write, and you can port between both iOS and Android. So there can be some quirks with a lot of with quite a bit with some of the ecosystem. It's neither of them are actually a Unix, even though we sort of make those assumptions unless it's got Windows written on it. So there's a bunch of things like Unix standard library functions that just aren't going to work. But you get a file system, you get sockets, you get everything supported in standard, and which is nice. But a lot of libraries in the ecosystem take a direct dependency on libc, which can cause some problems. They're not insurmountable, but you need to be aware of it. Most of the big ones come from the fact that 32-bit Android's libc is quite quirky, because it was only ever designed to run Java. So it exports lots of signed integers in its interface, which is you can get around it, but it's annoying. So to interface a Rust library on Android, you need to expose a JNI interface, which is really quite easy in Rust. There's a nice crate, unsurprisingly called JNI, which will do your mappings quite nicely. It does need a bit of unsafe code, but it's not the end of the world, and it's an interface layer. It's an interface layer anyway, so that's likely to happen. It's good. Yeah, it's not bad at all. It's not a bad interface. JNI is quite painful, but it's not a bad interface to it. So what you would do on Android is write the Rust library, and then a little JNI stub on top of that in Java, and then you would layer on top any interface functionality to your particular mobile platform. So if it was Cordova, you would write a Cordova style Java mapping to your JNI. If it's React Native, you get the idea. On iOS, it's actually a lot easier, the interfacing, because iOS is both Swift and objectionable C will accept a C ABI. So all you need to do is expose a C ABI from your library, and basically link it in Xcode, and it works. So there's no real choice about libraries for exposing a CABI and the appropriate headers from Rust. cbindgen does a lot. I think you can even talk to C++ a bit now, but that's advanced. So what you would do is you would set up a Rust build. So you've got a conditional compilation based on your target architecture, which either, if it's an Android architecture, it'll spit out a JNI interface. If it's an iOS architecture, it'll spit out a CABI. And if you're talking Rust to Rust, then you don't bother. So let's not talk about platform pages. It's a bit much. So that's how you write a library. But actually getting a going from a library from an application requires a few more additional steps, particularly on iOS. So Android, all you need to do is statically compile a shared object for an Android target, and then you feed it into your toolchain with the JNI interface and your Java stub. So that's relatively easy, and that works I've done this for both React Native and Cordova. I've never done it for a pure Android application, but that would be even simpler, I think. You would just import the JNI interface directly and work on it. iOS is a bit more problematic, and it probably might get more problematic, but the Rust community is smart, and there are solutions out there for what might be coming up. So the simplest way of producing a static library which will execute on iOS is what's called a fat binary, which you produce with a tool called Cargo Lipo. So a fat binary is basically it's a concatenated version of the static library for each target architecture, just in a single file with some Apple magic in it, which makes it work. I don't know the details. Ask a compiler engineer. So that approach currently works, and it will currently work on a handset, and it will work on tablets, but it won't work on the watch. So the Apple Watch now requires bitcode, and bitcode is, as I understand it, it's LLVM intermediate. It's LLVM intermediate language, packaged as a library, so that it can be compiled on the fly from the intermediate language to the actual target architecture, which is quite clever. But unfortunately, how Apple did this was by forking LLVM, and Rust uses LLVM as it's to produce intermediate language, but it doesn't use the version of LLVM that Apple uses. So there was a fork of the Rust Nightly compiler, which applies Apple patches to LLVM, and then you can compile, and then you can actually produce what should hopefully be a bitcode compatible library. So you can see how this might be slightly scary. I've not actually tried that in production, and that would definitely be something you'd want to spike before you committed to telling your boss that you're going to write a cross-platform mobile library in Rust, particularly for the Apple Watch. Hopefully, by the time this looks like it's going to become a universal problem and not just the watch, then there'll be a lot more eyes on it, because I don't think it's just me that tries to write cross-platform Rust components. There's a whole also quite a lot of people compile C and C++ and use it cross-platform, which you do, and then you use similar tricks. So once you have your universal static library, your bitcode library, or your Android shared object, then you just put them into your standard mobile toolchain, and then you come out with an application. There can be some development cycle issues with having a Rust build in there, with certainly with React Native. If you're regularly updating your native components, it requires a full application rebuild, which can be uncomfortable. But generally your interfaces don't change that much, and you should probably be testing the functionality of your component, not directly in the application. So yeah, I think that's it. It's quite possible. It is quite possible, and I have done it twice now. One application was a smart home interface where we had a Rust mobile component which was compiled for Linux for using tests and utilities. It was compiled for Android to use on both a handset and also on our embedded device, which was embedded Android. So we had the client both in like proper Android and open source AOSP Android on an embedded device, and also it worked in iOS. That component was relatively fiddly. You definitely wouldn't want to. We were a small team, and you wouldn't want to rewrite that many times. It did, MDNS discovery, quite a fiddly event streaming binary protocol and kind of stuff. And the second project was similar. It's not quite as justified, but it was a domestic router control app. So you go in, you MDNS discover a router that's has your that you want to connect to and do router configuration things. It's not particularly thrilling, but it discovers your router using MDNS, and then sets up a binary protocol, does a bunch of fiddly X509 things, all sorts of stuff that you really probably only want to write once. And that was made possible to do in a tiny team by the use of Rust. So, yeah, I think that's about it. Thank you.
All right, amazing. Thank you very much, Ryan. It was really, really good. So I think we're going to go straight into Neil's talk. So yeah, Neil's been using Rust for a few years. I think he's going to talk about generating open API clients for Rust. Jamie, do you want to do the switcheroo, the old switcheroo? All right, cool.
Yeah, hello. Let's see.
Hello. Yeah. Just give us one moment. Got screen. Oh, awesome. All right, cool. Yeah, go for it.
Cool. Hello, everyone. Yeah, so I'm going to talk a little bit about OpenAPI. And yeah, I'm Neil. I work as an SRE, and I got interested in OpenAPI a year ago or so because I'd written a Docker client due to my work. And part of the issue was I got several contributions, and it was kind of a bit of a headache trying to sync up with the remote changes that were coming in. So I always thought, you know, when I thought in the past about OpenAPI, you'd always see these APIs that were sort of a bit gnarly. You know, there's lots of functions and all these parameters all over the place. And I realized after working with it for a little bit that didn't need to be that way at all. You can sort of take what you need from it, and you can work with it quite well. So yeah, I'm going to be presenting a bit of the work that I did with the Docker API. It's a project called Bollard, and another API that I've written recently, and perhaps talk about what may come in the future regarding generating code with external APIs. So why would you do it? Why would you bother with it at all? I mean, at the moment, if you look at the Rust landscape, most people are sort of handwriting their clients. They're sort of hand maintaining it, writing models and trying to adjust to it as things come in. And what you see quite a lot actually is projects that have quite a sort of a nice initial push, but after a few years, maybe the passion would run out of the project, and you still have these external changes coming in from external servers, external services, and you'll get contributions coming in that try to fix, a small part of your API, and maybe sort of the quality across the whole API changes and is good in some parts and isn't good in other parts. And yeah, so there's a lot of focus at the moment, and you see it in the books and the online books about using Rust idioms for APIs and using really nice features, but there's kind of a little focus on correctness and maintainability over the long term. So yeah, here's just sort of a silly example of a model which you might have, and this came across actually when I was writing the GitHub client. There was just one endpoint that suddenly decided, okay, I don't want to give you a page in numbers, I'll give it to you in strings. Sorry, mate. And that's kind of the typical thing. You might have a nullable field, something that's like a field that's empty or just set as null in JSON. And yeah, boom, your static model just isn't able to deserialize it. So yeah, and obviously remote servers are difficult to test. Do you mock it? Do you seed the fixtures from the mock somehow, or how do you regenerate that? It's all a little bit difficult when you're writing an API client. And as a result, over the long term, you get bit rots setting in pretty quickly. Yes, so for proprietary stuff, it's quite common that companies document their APIs. Open APIs are standard. I've seen companies internally use different things than Open API. So larger companies that rely on HTTP, they will try to do that with their microservices. They'll try and document each one. So it behooves you to actually leverage that. I was trying to look a little bit for alternatives to OpenAPI, and I saw something called RAML, which was released by MuleSoft, but hasn't been updated since 2016. So in terms of just plain REST APIs, I didn't really see an alternative. I do think, though, that the future is probably going to be different. gRPC and GraphQL seem to be the main sorts of contenders, and yeah, those could definitely have different sort of tooling involved with generating code. Yeah, so there's a lot of emphasis at the moment on Rust semantics. So language features like, I mean, I think they're really great as well. Builder patterns, traits, and macros. But yeah, my sort of point to bring across is to try and make APIs more maintainable over the long term. And as I said, motivation for a project fades, and your API suddenly breaks without you knowing it. Yes, so I've mainly used the Swagger generator, and what's made it quite flexible is the templating language behind it. So you can kind of use what you want in some way. I mean, these generators, they generally split themselves up in building models, operations, parameters, and responses. So for my Docker API, for example, I decided not to generate anything but models, so that all the operations are custom written, they're still hand maintained, all the parameters and body parameters are hand maintained. You can lean quite heavily on the template language. Yes, most generators, they use Java underneath. I did see a Rust generator, but I haven't used it yet. I think support for Rust is only officially available in version 2 of the OpenAPI schema. I have used version 3 in my latest project. I had to write some Java for that. But in general, I don't think it was all that much Java. It was really just sort of templating a little bit of stuff. And one of the nice things about it is that you can sort of concentrate on other things as well. You can just generate that code and try and build on other features. Yeah, so just quickly on the pros and cons, improves maintainership over the long term. It's easy to concentrate on some other features that you might want for your project. And I'll show you that in a little bit with the GitHub API that I've written. It is possible to implement Rust idioms with OpenAPI generators. It just takes time, and you need to work with Java usually. And I think one of the biggest negatives for me was that remote changes mean you have to build in a breaking change into your versioning. And I saw that a lot with the remote Docker changes. They wouldn't bump their version or anything, and you'd have breaking changes in your code. So that was a bit of a thing that I'm not sure how to deal with at the moment, but yeah, it's not the greatest. So what kind of other features would you concentrate on? I mean, if you're generating everything, do you just leave it as some API that you generate? Well, the things that I like to do was to build on my dependencies to keep the latest Tokyo in, maybe to build the client in such a way that it doesn't use Tokyo with minimal dependencies. With the GitHub API client that I've written, I built in cross-platform support, so for WebAssembly. Yeah, and you can just offer a more diverse set and just build on other features that the Rust language can provide. So for Bollard, that's my Docker API client. As I said, I only generated the models. All the operations, all the methods that would call the API, they're still hand maintained. More or less everything was off the shelf. So copied over the Java code from the OpenAPI, the Swagger generator, and tweaked the templating a little bit. It uses a Maven POM plugin section, which pulls in the Swagger generator, and that lets you just basically use inheritance and use your own templates, your own class file. Bollard itself has become quite popular recently. It's used by the Timberia Vector log aggregator. It's one of the fastest log aggregators around. It's also used by other big projects like Stenciller, which is a document collaboration platform, and GraphNode, which is a protocol developing popular cryptocurrencies. And yeah, it has, so Bollard has quite nice traction and lots of people downloading it. So this is sort of the example of what it looks like. You would be generating the non-generated code would just be an operation, and it would refer to models that were generated by templates. So the host config and so on, and the container create response. So yeah, it's a mixed approach, and I think it's quite useful if you have some sort of Snowflake APIs that need some special code in them, or you want to make sure that the generated code doesn't look completely ugly. Yeah, and of course the parameters that get pulled in, they tend to refer to models as well, so that's quite nice as well. And of course, yeah, you can leverage the documentation that's built into the open APIs, and Rust has some of the best doc tooling around if you look at programming languages, and why not just use that. Yeah, this is a look at what the Maven plugin looked like for me. Obviously, if you're using a different generator, it will look a little bit different. But yeah, it's just a PON file which you use Maven to run over. You can just point to the remote Open API file and generate your files in the right directory. Yeah. So the other client that I'd written was a GitHub client called Roctogen. And I think that's quite a good sort of use case for generating APIs. And the reason for that is because the GitHub tends to change the API quite a lot. So we've had quite a bit of API churn in just this year. For example, I mean, the GitHub version 3 API has been around for years, right? And they've changed 12 endpoints this year with 3 completely new endpoints and multiple changes in one of the endpoints that existed for years. So if you were maintaining one of these clients, you'd have to just switch everything around. You'd have to move things around. And yeah, you see a lot of clients around. You see a lot of these GitHub clients, and it's really easy to actually write a simple one. So if you search on crates.io, you've got tons of GitHub projects. So yeah, it was for hand maintaining this sort of thing. It would be from my point of view, too difficult. And when I generated everything at the end of the day, it was like 100,000 lines of code. So wouldn't have done that otherwise. And yeah, so this is sort of an example of what it generated in the end. It generated errors, parameters, body parameters, models, and functions as well. I did manage to build in the builder pattern for query parameters, but it was a bit of a headache. And yeah, that allowed me basically to save time and focus on other things. So I mean, the API was generated, and I wanted to have to explore other things, like be able to target different platforms with the same code, to be able to run on WebAssembly, both as a serverless platform and on the web. I wanted to see if I could do sync and async at the same time. And these things, I think, are quite important. I mean, a lot of people come in and they say, oh, I don't want to have Tokyo and all its dependencies, or I just want to have a simple client that does this and that, or maybe I want to run it here or there. And as an SRE, you often think about, can I run this on a Lambda, or can I run this on some other serverless platform? So yeah, all this time saving basically allowed the client to be abstracted in that way. So currently for Octogen, it supports Isaac. It's sort of a wrapper around curl. And aside from that, obviously WebAssembly. So, oh yeah, and I'll try and demonstrate that. If I can reshare my screen somehow. Can you all see that? So yeah, here we've got yeah, just a small demo of using Octogen. And for you that don't know what Cloudflare is, it's a service that runs serverless platforms in WebAssembly. It's got really nice Rust support. So what you do is you end up compiling your code down to WebAssembly. It uploads it to their servers and runs it there. So yeah, the code itself is just a simple fetching the commits in a repository. So this will compile the.
Sorry, I don't think your screen share is working.
It's not working, is it?
It's just a black screen.
Do you see anything now? No.
Yeah.
Yeah.
I think so.
So the code that I showed before is just a small script that checks gets out the commits from a repository and emits them. And I compiled it using the WebAssembly tooling that Cloudflare has and uploaded it. And this code is then run on their servers.
He's sharing the screen still, not a terminal, something else.
Are you seeing the web browser?
Yes, still seeing the web browser.
Are you seeing the terminal window?
No.
No.
That looks better.
So code is fetching the commits of the repository and emitting them. And when I compile it like that, it'll actually open a browser window. Which looks like that. Fetching the commits in the repository This is run on the Cloudflare worker, so it's not client-side code. It's serverless code. The sync demo is just running the client from your local machine using the normal Rust regular binary. Doesn't look much different, using the same API functions. Web is JavaScript client. So I'll just show you the code now. It does a little bit different because it needs to create, needs to get a div in the page, and it'll call the same functions in RoctoGen, and it'll add the result to the div. So this is client-side code. This is all running in JavaScript. And the nice thing, of course, is that you're just using the same code for each of those. And you could target multiple platforms in that way. And people that want to use the client for a particular platform, they wouldn't need to use a different open source project, or they could just use the same thing. So yeah, that's all I've got. Happy to answer any questions.
Hi, great. Yeah, thank you, Neil. That was really interesting, and thank you, Ryan, as well. It was also a really interesting talk. Missing doing my Rust dev, seeing all that code up, it makes me very jealous that I don't get to do that on a day-to-day basis anymore. But never mind. Cool. We're going to dig straight into some questions. We got a couple that we picked up during the sessions. If anyone's got any more questions, please add them to the comments now. We'll try and pick them up. Jamie, I think you have to.
Yeah,
you have something interesting you can do here.
Yeah, you can pick them out from the chat and sort of stick them on the screen, which is somehow anyway you should be able to.
So I guess.
Yeah, there you go. That works well nicely.
Yeah. So the question is, so did you generate the Rust using OpenAPI files as a one-time thing, or were you using macros to regenerate the structs on every build? And I built. It was all generated as a one-time thing. It wasn't using macros at all. Would have been nice to use macros, but obviously if you're generating things, then generating macros and then having macros generate more code gets quite complicated. So, yeah.
Cool.
Yeah. Just passing back through the chat and seeing if we can. So I asked one, which it's further up. Do you know of any good libraries for GraphQL stuff? Just out of pure interest, really. If it's fine, if it's no.
No, I don't.
Yeah.
I do for other languages. I wouldn't want to talk about them.
Yeah, in Rust.
There is one I looked at briefly with a spike headed, but I can't remember its name, and I don't know if it's good. So
yeah, absolutely. There's a question further back about, I think it's about oh gosh, it's all the way back at like 7.10. If you have a look for that, Jamie, that's probably a good one to start with.
If you can't find it, I can just read it out. I've got it.
Yeah.
Yeah,
It's just
read it out.
the picking out's really nice. That's all.
Yeah.
We're paying for the features. We're going to use them.
It's from Ajazam. There was a question: what tools do you recommend for Rust development on ARM? I think that's probably more aimed at Ryan.
ARM as a target, or ARM as a compilation environment. So, I mean, the best way, the easiest way to target anything if it's supported is with Muscle. So that produces really nice that produces a fully static binary with no libc dependency. Unfortunately, you can't do that on Android, but you can do that on ARM Linux targets. So if you have a Linux ARM target, I'd recommend Muscle, which is really easy to integrate with Rust. If you want to know how, drop me a line.
Yeah. And then there's one from 726, which was a bitcode library is just a file of LLVM instructions, isn't it? Yeah, there you go. Nicely picked out.
As far as I understand it, I think we have an actual compiler engineer in this room, so we could probably give you a better answer. But yeah, it's a bag of like some LLVM stuff and some Apple magic, as far as I understand.
Yeah, absolutely. Yeah.
There's one more I'm going to put up.
Yeah.
Yes, I did.
Absolutely. Keeping that for posterity, then definitely. Let me keep going through the chat. See if there's any more questions.
There's a question from Rick Newton at 7:53. This
one. Yeah, there you go. That's.
I mean, I guess it's a language choice. So I was using Rust for a client because we wrote a lot of the server software in a lot of firmware in Rust. So it was just easier to write a client that consumed it in the same language because of all the words we're going to buy, etc. So I guess you could do it if you're Swift's a pretty nice language. So why not?
Yeah, I think if you don't, it doesn't work on Android, I believe, Swift. So.
Okay, that would be a problem. I didn't know that.
Yeah. Please tell me if I'm wrong there. In fact, yeah, I'd really appreciate if you did tell me I was wrong. There was a question from Rick Newton about how are people finding Rust build times. There you go.
I suppose that, for everyone, I guess.
For everyone.
It's unfortunately been a while, but they get better and better. There's what's the name of the site which it actually integration tests and shows you the deltas in Rust C compile times against like a bunch of standard projects. So if I can remember the name of that's the best thing to look at, I think.
It's perf.rustlang.org.
Helps if your IDE is set up properly as well. Let's get LSB with it, and then things seem to be faster for me at least.
And that suggestion there to use Clippy to check for errors first and then do a build. That it can speed things up.
Yeah, absolutely. There you go. There's another one. What IDEs do people use? That's an interesting question. Yeah.
Well, I use Neovim, but the latest head one, that's the pre-05 build.
I'm a well-behaved professional consultant now, so I'm trying to use VS Code, but I usually prefer. I've used Emacs for years with Vim emulation, but I dip in and out. Tools are tools, really, as long as they work.
Yeah. I've used the bits of Rust I've played with. I'm the other way because I've come from like Java and then Scala. I use what's it called? Their equivalent version. I'm looking it up. Sea Lion. So it's like IntelliJ plus the native tools. and then you can kind of layer Rust on top of that. And I quite like C-Line. It's good. Obviously, like, it depends on what your mindset is with tools, right? I don't mind if they're a little bit heavier weight, because I quite like them to be quite big. To each their own. To each their own. Jamie is obviously an Emacs person.
Yeah.
I say obviously, I just know that he is, because he used to tell us about Emacs all the time at work.
Yep.
I
actually have a question for Ryan. Do you have any issues getting Rust code through the Google and Apple's infamously picky store acceptance process?
So, we've never actually put a production Rust app through iOS. We've had it. So potentially that is an issue. Yes. I mean, the mystery of Apple's approval process is our main difficulty with that project was actually the hardware, and also with the last project I did involving a router, because it's very difficult to come up with a way for them to test stuff against hardware that you can't send to California for them to test against, especially as a small company or as a like disorganized large company. Open question. It works. It'll definitely go in Google Play, and game developers do worse. So, I mean, game developers will stick all sorts of stuff written in C on mobile devices and get it past approval. So, no.
Yeah.
Cool. Good answer. Do we have any more questions? I've got a couple of general ones if nobody's asking.
I haven't spotted any more in the chat, so go on. Let's go for the general ones. I think
general ones, yeah, they're sort of open to the floor. As like, obviously, when I learned Rust, it took a long time. It took probably 2-3 months of me doing it every single day before I learned it. Does either of you got any advice for someone who's just picking up Rust and wants to learn it?
I think it really depends how you learn. I mean, I'm pretty old, so I have to be paid to learn effectively. So, I mean, I like learning things. I like to engineer my environment so I can learn things, but I can't just sit around and learn a new language without some kind of external motivation. I prefer to go sailing. But I mean, the core of that is I do actually need to build something concrete and preferably like semi-useful, rather than just mess around with Hello World or Advent of Code, which is cute, but I don't think it doesn't teach me anything.
Yeah, find something at work that's not so important, like a tool, some tooling for yourself or for your team, and write it in Rust. Don't tell anyone, and just say, here you go.
Yeah, that's the exact thing I'm going to do. I'm just one day going to be like, oh yeah, I built this thing in Rust, so have fun with that. Just add it to the list of languages that you need to hire for in the future. It'll all be fine. Everything will be okay.
Yeah, that used to be the issue. We're looking that we've now got 34 people on the call. I suspect that will be less of an issue in the future for actually hiring Rust developers.
Yeah, absolutely.
It's great news.
Guess I'll put that on there. Just someone recommended that as a way to learn Rust, which I agree with it.
That sounds interesting. Yeah,
I did Lisp a long time ago, so linked lists are kind of bread and butter for me. So, yeah. Cool. I got one other question as well. What certainly my experience was with Rust was that the crates and the standards of libraries, in particular, if you were brave enough to hit the sort of bleeding edge nightly versions of Rust, they changed very frequently when I used to use it. This is going back over 2 years. What's your current experience of sort of using Rust in production environments?
it's got a lot better. So there were two big pivot points. One was the stabilization of prop macros. Obviously, we were on nightly for reasons. And then there was async being integrated, and I think the ecosystem has recovered from those two shocks. And it's things do. I'm unfortunately not using Rust day to day for the last few months, but things have got a lot less churny.
Yeah, I can't really comment too much. I mean, we do use Rust in production at work a little bit, but it hasn't really been pervasive, and it's been quite stable for us, actually. One of the nice things is that it tends to just work, so you don't get that sort of issue with sort of dynamic languages where there's always something that's broken, you have to go in and fix it.
Yeah, my experience of Rust was, I think it just hit version 1 the first time I fired it up, and so yeah, it was supposed to be stable at version 1. I don't think it was. The language was, but nothing else was. So yeah, it was. I'm glad that things have moved on a lot since then. Great.
I'll throw one more in before we finish up. What's one thing that you would like to see in Rust? What's one change you'd like to see in the language, or one thing you'd like it to improve with, or something like that? That's a sort of, yeah, to anyone as well.
IDE tooling, editor tooling. I mean, that really is where it falls down. It's getting better, but yeah, they didn't design the compiler originally to do that. They designed it to make really nice executables. But it would be nice to have a better editor experience, and it would also enable the use of the more casual use of macros. I mean, there's if a macro blows up and you get nothing in your editor environment, it's just bloody nightmare. So yeah, static code generation approaches, but it's still more viable than rather than saying F# type provider kind of stuff where you can lean on the editor to do exploratory stuff. There's just no way you can do that currently in Rust.
Great. I think if
Cool.
there's no more questions, just want to say thanks again to Neil and Ryan. Amazing talks, and so great to. There's another question for you, Ryan. Just came up actually.
That's the question I wanted. Yes. She's a 33-foot 1974 motor sailor who's quite cute. Usually quite cute. Currently, she's a building site.
It's certainly the most unique place I've had someone do a talk from at any meetup I've ever seen. So absolute props for that, definitely.
Cool. Yeah, so I think we should just show our appreciation to Neil and Robert. If claps and crap emoji.
Careful.
Well, I managed to get all the way to the at least the talk's gone before I make some mistake. That's good. Crab emojis, please, in the chat, and thank you both.
Yeah, absolutely.
Round of applause. I like that.
Yeah, that's good. That is good. Cool. So yeah, I think the other thing, as we mentioned, for us who are running this and for doing Rust Manchester, is we'd really like to know what sort of stuff people want from a meetup like this. I appreciate that that's kind of a very open question, and a difficult thing to answer, but is it talks? Is it not talks? Is it a mixture? All that sort of stuff. For now, shove that, put that in the comments, and we'll read them. In a bit, we might throw a Zoom link out, and we can get some people on that. But yeah, generally wanted to kind of open up and say, you know, what do people want this thing to be? Because we're you know, we're starting from scratch and we get to kind of define that. There is one question: do you have any plans for a post-pandemic world? I don't know. I think we'd like to do this in person, because I think everyone would like to do anything in person at this stage. But I think that you know, obviously when that world will be is an open question. No one really knows the answer to that. And I think some level of online presence is kind of good for meetups in general. So I feel like that's part of what we want to kind of shape, you know, with this kind of thing. Yeah. What's that? Request for help, offers of help for ongoing Rust projects. That's quite an interesting idea. What do you mean by that? That's what I'd ask. What does that mean to you? Yeah. In person is difficult. In person is difficult. I live in Rotherham. Yeah. So this is one thing. Like in person, obviously we've kind of badged this as Rust Manchester. But that, if there's one thing the pandemic's done, it's allowed people that don't live in kind of these sort of tech centers like London, Manchester, and such to actually like get some of this stuff.
You don't even have to be on dry land.
You don't even have to be on dry land. Exactly. Yeah, it's the future we all wanted. Yeah, I think, you know, we want to try and do something with that. I don't quite know what yet. Yeah, let's have a look what else we got in here.
We could look at streaming if we do go back to in-person events, to stream it and have both going.
I think that would be cool.
If there's demand for it, I suppose.
One of the good things with streaming it is that it also means we can record speakers and give them a recording, which is useful. A lot of speakers do want a recording quite often, so yeah, that is a useful thing to offer. Yeah, I think, you know, in general, we kind of want to shape this, and so like I don't expect the audience to give us all the answers. It's more just like, yeah, what is the right thing, you know? Yeah. So we might move over to Zoom soonish, although please keep posting in the Twitch chat. But yeah, we want to listen to people, and I suppose you can also get in contact with us. You can get in contact via Meetup, right? Am I right in thinking that? I think so.
You can send messages to the organizers on the Meetup group. Yep.
Yeah.
But we're also on Twitter. And I think most of our details are also on there somewhere as well. So
yeah.
We can probably share some information of how people can contact us.
Yeah, absolutely. All right, should we maybe head in the direction of Zoom and see who joins us? Do we want to go for that? Yeah. Okay, let me get a Zoom link.
Zoom means that other people than us can talk and be on screen.
Yeah, exactly. that will be part of the experience.
You don't have to be. Feel free to watch.
Yeah.
But yeah, it's just allows it to be a bit more interactive.
Yep. Right. I will drop off this and then I'll send a Zoom link, and if someone can post it into the chat, and we can go from there. I suppose that's probably the way forward. Right. Okay.
Yep, thank you for joining. Anyone who wants to drop off, of course, Zoom is not required, so feel free to drop off if you want to.
Well, Zoom is pub equivalent, right? I've got some cider.
Yeah, I think I might be going to get a beer if there's some Zoom conversation going on. Yeah. Oh, he has posted it. I've just missed it.
Where is it? All right. Oh, yeah. So,
right. We'll see you all there. in a few minutes.
There we go.